Good afternoon, everyone. I'm Kuldeep. I'm from Expedia. I've been doing building tools and platforms around AWS or cloud computing for the last 4 years. I'm here to talk about how Expedia is using serverless architecture. Again, serverless is not just Amazon AWS Lambda. There is API Gateway, DynamoDB. As Werner also mentioned this morning, it is not just Lambdas. The intent of my talk today is again, as I mentioned, I'm from Expedia. Expedia is one of the largest online traveler industry out there. Right? We are operating in 75 different countries with more than 100 points of sale. Our mission is to revolutionize travel with the power of technology. Right? We love travel, and we want to simplify the travel for our customers with the power of technology. So, agenda for this session, I'm going to talk about Amazon Lambda usage at Expedia, how many transactions we are doing now, and how much do we spend for that amount of compute that we use from Lambdas. And then also do a demo of how we have created a platform so that people can, like our team members can go and create a Lambda. So I'm going to create that and do a live demo of it as well. And then I'll cover different serverless apps that we are running at Expedia. I'm going to cover 4 different patterns. Right. So again, this is our current usage with Amazon. We use almost, I won't say almost, but there are a lot of Amazon services that we use. With our current infrastructure, the platform that we built, we call internally Primer. We do around 1,200 deployments across the globe. These are not just production deploys. These are also test, dev, everything. I'm not just talking about production. And we have more than 700 engineers using Amazon. And then we have about 600 microservices deployed in 6 different regions across the globe. So that is our Amazon usage. And if you look at the Lambda usage, particularly, we do about 2.3 billion transactions a month. And about 200K hours is being spent based on different Lambdas that we have. Right? We have about 600 different Lambdas, I think, or around that. But we spend only $550 for that. And as Werner mentioned in the morning, you pay for even by milliseconds, right? Like it's 100 milliseconds what they charge you, and even and also by memory. There's also an interesting one that I'm going to show later on of different architectures that we follow, and I'll show how much we spend as well. But the biggest one that I wanted to get out of this session is the opportunity more than the cost. Right? So there are different possibilities that you get with Lambda that you can't even do with ECS. You can, but you have to build a lot of infrastructure around it to do that. So that's what I wanted to present. As a quick refresher, what is Amazon Lambda? You can run different code platforms, right? Node, Python, Java. And there is no server that you need to provision. Amazon takes care of the provisioning of the server. And you're basically running a function out there. And there is no administration, zero administration. There is no operations that you need to deal with. And then it also scales based on your the number of requests that you send. It scales. Again, you have to be very careful when I say scale there, right? If you're running in the VPC, then you need to make sure you have the enough IPs and whatnot. But if you're not running inside a VPC, then I think it scales infinitely. And then as I mentioned earlier, the cost that Amazon charges you is by sub-seconds. Then how it works, right? So you write your code, whatever that it is, whether it is Node, Java, Python, then you upload that into Lambda. Basically, you can upload to S3 or whatnot, but you give it to Amazon's Lambda to run that. And then there are different event triggers, right? It's an event-driven architecture. You have SNS that you can do. You can use API Gateway and just make just a HTTP call to it. And then Amazon Lambda runs. Again, as Werner mentioned, it is a single-threaded application. It's not multi-threaded, the Lambda executions. And then you pay for what you use, right? And the maximum you can only do is like 5 seconds. You can't do more than 5 seconds. So again, just it was a quick refresher on what Lambda is. Again, earlier I mentioned serverless. When I say serverless, Lambda is only one part of it. It is just the execution layer. There are other parts of it, but I'm going to show a little bit on the demo of how do we create Lambdas at Expedia. So we have a platform that we internally built, we called as Primer, so that it helps teams to create different types of apps. It could be a Lambda type of an app, Spring Boot, Node.js, Spring MVC, you name it. We have about 26 different types that we have. For this talk, I'm just going to concentrate on the Lambda part of it. As a user, you go to that page, right? You log in with your credentials, and you can see it says you're focusing in our apps, not on the infrastructure, how to build my infrastructure, how do I deploy. So that's what we are enabling our users. And all you go in the page is, hey, I am going to create a Lambda, and have an idea that I want to try out, and you just enter the name of the app, right? And then there are few things that you need to enter, like the team name, so that we can go and tag the resources, not on Lambda, but in general, right? Like if you're running EC2, ELBs, and whatnot, so you want to actually tag them. And there are a few things which I'll go through when I do the demo. And then once you are done, this is the page that you get. I think the Lambda creation process is like 2 or 3 seconds today. When I say Lambda is created, what happened behind the scenes is we have a templated source code which says it's a hello world app. Anything that we do, all the different templates that I mentioned are just hello world. But we do have unit testing on the app as well. And there are a few things that we do here, right? Like because it is a Node Lambda, there is nothing that we need to deal with a Docker registry or whatnot. So some of the steps will be skipped. And then once this is done, you get an email which says, hey, this is the source code, which you can go and make changes, whatever the changes that you want to, whether you are talking to SNS, whether you are talking to the request coming through API gateway, whatnot, whatever you want to, you configure it and check it in, and then the Lambda will automatically get deployed. I'll show that as well now. Yep, so I'll do the demo. Hopefully the demo guards are with me. Okay. So as a user, as I mentioned, you go to this page, you get some details, and then if you go to this templates page, right, this explains different types of templates that we have, and all of them, as I said, it's more than 27, I think. And you have your Node.js one, and it explains what the template is actually, right? And as I'll do it, I'll create a new Lambda now, right? So I'm just going to select Lambda Node.js and something like maybe 1. The team name, right? To go to so this is all required for you to tag your resources so that you can do showbacks and whatnot. So there are different line of businesses that we have. So all you do this, and we heavily use HipChat for all our communications. There are some teams who use Slack as well, and people have plugged in sending notifications to Slack as well using Lambdas. Oops. It's funny, it says 61.54, 76.92. But again, it is done now, right? Like it is done. The app, whatever that I asked, hey, go and create this repo for me, it is done right now. I can go to the repo. So I usually get an email. I didn't want to open my email. But this is the repo that it created right now live with a sample source code. I'm going to clone this, and I'm going to show what all it actually does as well. So as I mentioned earlier, we also do a unit testing for them as well, right? And you'll also have code coverage. So we use Jasmine for testing, and we have Istanbul for doing the code coverage, right? So this is all you get for free. And let me run this in the back end. So So this one is just basically, it's a hello world thing, right? It's basically, we are giving you the boilerplate as a user, as a team member to go and do whatever you want to. But all you get is this hello world, and you also have a test, right? So the test says that basically needs to be hello world, right? So as a user, you can make changes and then make sure your tests are running. Hopefully this is done. Okay, this is done. So I'll just quickly walk through this and right. So and you run gulp, then the gulp should fail, right? So the gulp is saying, hey, you said in the test it's hello world, but you said hello reinvent now, so it failed. And as a user, you just go and update it, and so now the test has passed, the code coverage, everything is good. The one that I wanted to show is this part where, as I mentioned earlier, there are different event types that your lambdas will trigger off, whether it is SNS, S3 file creation, or object creation. So as a team member, you can say, hey, my event source is something from SNS. You add that in, and then you check it in. That's all you are doing, basically. You're not doing anything beyond that. And the deployment framework actually takes care of it. For most of our deployments, again, as I mentioned, primary is the platform, but most of our deployments happen through Jenkins. So all it is doing is calling a Jenkins job to do the deploys. I hope I have it here. Right, so the one that I earlier kicked off, it's already deployed. Again, now I can make a small change and then check it in, and it will again go and deploy them for the user. I'll also go to the AWS console to show that it's up there. And this is how we enable CI/CD for our teams, right? So it's not only just we give them the option to create a new Lambda, but you also have full CI/CD. As you make changes, you just commit to your master, and everything else happens for them. So let's go to Lambda. So this is the one that I created right now. So with that, again, this is what we have built for our team so that they can focus on innovating, writing apps versus how to create Lambdas, how do they wire up. So that's what I wanted to show. Actually, let me switch back to my slide deck. So with that, again, now I really want to focus on 4 different types of architectures that are currently in use. Again, there are many more. I'm not going to cover every architecture that we have. The first one, our CI/CD platform that I showed you right now, the changes that I was making, all the metadata that you see in our dashboard, everything, most of it actually runs behind the scenes with a lot of Lambdas. We call them as minions. So that's what we call them internally. There are like 20 of them or 30 of them. I don't know. There are so many minions. And each perform different tasks, right? One is sending a HipChat notification. One is writing to Elasticsearch. One is writing to DynamoDB, based on whatever that event is. Again, most of our, as I showed earlier, most of stuff that we do is GitHub Enterprise. We have it hosted internally. So as a user, you're making the change to GitHub, and we use GitHub Webhooks. Then any change that you make, that gets pushed to an API gateway. So there is an API gateway endpoint that we have. Any thing that we do in our GitHub Enterprise, there is an event that gets triggered, right? So that again calls a Lambda. And in that Lambda, there are, like for that one particular event, there are like 20 different Lambdas that are listening on that same event. And then every Lambda has a different purpose, right? Like it looks at that event and says, hey, this particular one is interesting so that I have to update the deployment config. How many minimum instances, how many maximum instances. There is other one where we enforce, at least guide our team members that you don't merge your own pull request, or you don't push directly to master, right? So that's one other use case. But everything is done by inspecting that same payload. Again, as the Lambda, the SNS. So here, the part that I mentioned is it figure out, there are different Lambdas that are running. Once they figure out what it needs to do, it will send, again, events to different SNS. It's not just one SNS there, but there are like another 20 different SNSs each Lambda will trigger. So one of them basically, right, one SNS is basically powering our deployment config changes, right, and it writes to Elasticsearch. Like it's Amazon Elasticsearch that we use, and we cache our data there. And then this is the one that I mentioned, right? Like if a developer pushes the code directly to master, there is another Lambda that's there, and it actually sends an email as well, right, saying that you have pushed your change directly to master. And basically, it is at least a guidelines that we are providing to our teams. And then the other one is basically all the changes that I was showing in the app. Basically, they also go and get registered into a DynamoDB, right? So, and all this is 9 million computations that we do for a month, this particular use case, and we spend only $1.8 for that whole thing, right? The amount of time it spends is far less. It's nothing transactional there that it needs to run so much hours. So, and it's about 350 hours, I think, yeah. And it's $1.8. That's what we spend for that particular platform that we have. Again, I'll do a demo of this to show that how it works, and then we'll go through the other use cases that we actually have. So I created an app before I came in. So this one is the Lambda. So if I go to the same app in our dashboard that I'm trying to open right now, right? So you can see that the team, it says here as primer, right? Again, the other part, we gamify our deployments as well. That's the reason you see that Go score. We actually did recently a blog on our official blog post on how we actually power that. Again, I'm not going to go into the details of that one. So I'm going to change the team name and see how, and see that it gets reflected. I'll also show that in the different Lambdas that are running this thing. So if I go here, so this is the metadata, right? So this is where it says as primer for the same app. I'm just going to edit it. Again, please don't merge to master directly. I'm just doing it myself here. Right, I just changed the team name here. I'm pushing it to master. I would have already got an email by now, right? Because I pushed to master myself. It didn't update yet. Okay, we'll come back to this. So these ones, as I mentioned earlier, there are different. Right? So this is one of them, right? So one of these Lambdas, the minion Lambdas that we have, there are different Lambdas that we have. And based on the data that came in, all it is doing, it is parsing the JSON file, and it is writing to DynamoDB, right? And there are different events that are running here behind the scenes to record this. Hopefully this has changed. Oh. Okay, looks like I'll take a look at it later after I go through the other slides. And if I go here and search for different minions, so you can see there are a lot of minions that are running, and each one is serving different purpose, right? Like one is writing to Elasticsearch, one is writing to DynamoDB. There are different use cases that we are trying to solve, and this is the one that sends the email as well, because you push directly to the master. Yep. So The second one that I wanted to talk to, I think there is a session as well on this from Amazon. So how do we govern our infrastructure, right? Most of them is driven through automation. Everyone goes and creates the instances. Most of them. There are a lot of folks use different tools as well. But there are a lot of users who have console access as well to go and create the instances through AWS console. How do we make sure that the necessary tags are in place? So that's this particular use case, right? So again, we looked at different services that Amazon offers to do this, right? First, we looked at AWS config to do this. Config records all this data as well for you. But again, and then you can write your own Lambda or your own custom config rule to do this. As we were looking at with config, it was getting a little expensive. I don't have the real numbers, but it was expensive than doing the other way with CloudTrail. So that's the reason we moved into using CloudTrail. Again, CloudTrail, for those who don't know, it records most of the API calls that you are making in Amazon. It records most of them. There are few, I don't know if they still record, like some of the KMS stuff may not be there. And when you have enabled CloudTrail, what happens is, I think it's, I don't know the time frame whenever the file gets created, but on a schedule, there is a S3 file that's created that has all the events that have happened for the last, like maybe 2 minutes or 3 minutes, and then it's uploaded to S3, right? And what we are doing here is, we have a CloudTrail, this is the CloudTrail event, which is a scheduled one that runs on a schedule, and then goes and gets that file from S3. And then there is a Lambda that's running on it, which is getting that file, right? And it is writing to a DynamoDB table, saying, hey, these are the events that have actually happened, right? And after that, we have this scheduled Lambda that's basically using CloudWatch events. That's what we are doing here. And then it actually sends a message out saying that, hey, go and look at the data that we have in the DynamoDB and see what you can do on that, right? So this one basically, again, everything here, it's DynamoDB, SNS, and API gateway. So if you see, most of them are that, right? That's what we are using here. So then what happens is, it goes and looks at that event that's there in DynamoDB, and it validates based on the rules that we have defined. So we need I think we have 4 tags that you need to have. Like one is role, one is team, portfolio, and product area. And if those tags are not there on the resources, that's when we basically operate on top of it. The other thing that we do in this particular validator stage, I don't know how many of you guys know, when you create an EC2 instance, does the tags go onto the EBS instance? Right? So that's a huge problem, at least for us, right? Because you are creating the instance always, but the tags are not automatically getting flown to the EBS volume. So part of this validator Lambda, what we actually do is, in the payload that you get from CloudTrail, there is also a parent attribute. So what we use that parent attribute, and then we automatically tag the EBS volume as well. Let's say that particular event is create volumes. That's what came in as the validator Lambda. It inspects the payload, and then it goes and gets the tags from the instance, and then automatically adds that to the EBS volume. So that's how we are ensuring that the EBS volumes are always tagged. Prior to this, we had to run a batch job once a day, which scans all of the EBS volumes that we have, then figures out what is the EC2 instance that's associated with that EBS volume. Again, this has saved a lot of things for us. But the main intent is not that. The main intent is to make sure the required tags are there on the instance. So once it validates it, again, it sends an SNS when it sees that there is a particular resource that doesn't match that particular, like the 4 tags that I mentioned, right? We do it for EC2, we do it for S3 buckets, we do it for EBS, we do it for load balancers. There are a few more that auto-scaling groups as well, right? And then this is where the Lambda comes in, the one that actually goes and operates on it, and then actually just terminates it. Usually by the time that you have created, we give about 15 minutes. And after 15 minutes, if it is not tagged, it actually gets destroyed. Right? Again, there is an SNS event that's sent out when that particular event happens, and then there is another Lambda that's watching for it, and it writes to the DynamoDB here. There are two types of DBs that I showed here, right? One is a simulation mode, and one is history. Sometimes there could be some issues that are happening behind the scenes on Amazon or whatnot, and we don't want to, even the instances that are created through automation, we don't want them to be terminated. So we can turn that on and off, the simulation mode. And if it is in simulation mode, we record everything, but we don't actually operate on it. But with the simulation mode, when you want to really operate on it, you can go back and then act on it. So that's this one. Again, I'm hoping this, I actually created an instance before we started. Let's see if it is there, if it is. We actually have a dashboard as well that shows all the events that have happened. Let's see if I have it here. So this is the table, UI. So when you create a EC2 instance from the console, the API behind the scenes is basically run instances, right? So that's what I'm doing. And the environment that I did this is in, so right before when we started, actually created this instance, right, at 12:55. And you can see it is actually in a terminated state. The reason why it is terminated because there were literally no tags on that instance. And if I go back to the same UI that I was trying to search, let's see if I can find it now. Okay. What is this instance ID? You can see this is the instance that it operated on, and it automatically terminated it because there were no required tags on it. If that instance had that 4 tags, whatever the tags that I mentioned, it would not have deleted it, right? So that's the use case that I wanted to show. And this is how we are ensuring that whatever the governance that we want to put on our infrastructure, those are always in place, right? Whatever automation tools that you use, whether you use Chef, whether you use Docker, whether you use Ansible, CloudFormation, just at least you need to make sure that the necessary tags are in place. Okay, go back to my slides. So we do a lot of A/B testing at Expedia, right? So we have a infrastructure that has been built on top of DynamoDB and Postgres database, right? The part of the talk here is, before this particular use case was done, all the aggregations used to happen in Postgres DB itself, right? Like when you want to generate a report on what actually all the tests that have been run over a period of time, that was a very expensive query that used to run on the fly in the DB. Then we used to, our CPUs, our memory used to peg a lot. So what we have done is, again, every change that you make on the, every changes that are run through the A/B testing platform, they actually go to a DynamoDB. So we use DynamoDB streams here, right? With DynamoDB streams, a Lambda gets triggered, and then what it does is it just writes that messages to SQS. So all the messages are just gone into SQS, and that's where the initial part is complete. Then what we actually have is a backend thing that runs on a schedule. Or actually, it's a streaming job that's running. So we use Spark streaming. So the Spark streaming actually goes to SQS, gets all the messages that were done for the last, whatever the time that when it ran previously. Then it writes to a S3 bucket using an internal app that we called as collector, right? And there is another Spark job that goes and massages the data and creates all those aggregations, and then directly writes that to the test and learn Postgres DB, right? The benefit here is we have offloaded all the changes to a different system, and we are not doing any of the heavy lifting in the DB. Everything else is done off, by the Spark system here, and then it just goes into Postgres aggregated, so you're not doing aggregations on the fly. So this is one of the use cases that we have. So this one, The other use case that we are running Lambdas, again, how many of you have used auto-scaling scheduled actions? Yeah. So with scheduled auto-scaling, right? You say, hey, this is the time that I want to scale up, and this is the time that you want to scale down. And it works for most of the cases. But the problem that we are trying to solve here is, we have this app called as Expedia Suggest service. This is the Typeahead service that when you go to the UI and then search for the app, right? Like search for Seattle, search for Las Vegas, it gives you some suggestions. So that's the app. It's used across different systems, right? And in this one, every day, there is a memory refresh that happens. So when the memory refresh happens, it actually, the heap usually, most of the cases, doubles the current heap size. So we were running into issues with the heap size being almost the double. The instance performance was not good, or you actually had to add more instances to the system, right? And so if you look at the graph here, right? So this is the typical heap size that we run, and whenever the memory refresh happens, the heap size goes up almost double. And again, you have to, the service gets degraded sometimes, or you actually have to over provision as well. So what we did with Lambda and auto scaling, yeah, so this is what I mentioned. So what we do is we actually have a Lambda. Yeah, there is a Lambda that runs once a day, right? And whenever the memory refresh needs to happen, it goes and looks at the auto-scaling group that the Expedia Suggest service is using currently, and it goes and tags it, right? Like saying, hey, I'm going to do something right now if the tag doesn't exist. And it also records the current instance count. What is the desired? What is the maximum? What is the minimum instance count it has? And then it goes and doubles it, right? Whatever is the current count, it goes and doubles it. And then we let the auto-scaling group to like kick in the number of instances that it needs to launch. So I'll show this as well. So there is a Lambda, it's a CloudWatch events based Lambda. It's a scheduled Lambda. And then it's going and operating on the auto-scaling group. Then it adds the tag onto the box with the minimum and maximum instances on it, right? And if there is an error, it just stops at that point. And we also do the oldest termination policy, so oldest first termination policy, right? And then we let the auto-scaling group to scale up. And then at that point, this particular Lambda's work is done, right? So and now we actually need to scale down, right? Like if we don't scale down, you're continuing to spend money because you have said, I want 2x of the instances, not just x, right? So there is another Lambda that goes, right? Then it is searching for that auto-scaling group that Expedia Suggest service is using. And then it looks at the tag. So if that tag exists on that auto-scaling group, then it goes and checks if the load balancer has the, it checks the auto-scaling group to make sure all the instances are in service, right? So we want to make sure that it is in service. And then it also sees, once that it validates that all of the instances are in service, then it actually makes the change on the auto-scaling group to go back to the old values, whatever the values that were set in that tag. So that's what it does. And then once it is done, again, it exits at that point. So this is how we are doing auto-scaling as well on our instances. Again, we could have just done scheduled action, but we don't get that flexibility of scheduled action saying that something is done. So hopefully Amazon is able to add that as well. Again, this is not Lambda, like Amazon Lambda, but it is a Lambda that we run internally using a platform. We call it internally as Hendrix, right? So again, I just wanted to give an idea of how the system has been built, right? There are different event sources, the same way that I mentioned earlier, right? So you have different SNS events that are coming in, or different API gateway requests that are coming in. So which is what I have it here as sources, right? And there are a lot of, and basically these are all different signals that come in. So and the lambdas that I talk here are also created through the same primer automation that I mentioned earlier. And then what the lambda here is the again, the lambda here is just a function. It is not a big microservice or anything. It's just a Scala function. And the way that we do this is you have DynamoDB has the metadata about where the file is, where the source code is, and then you have and then S3 is where the source code resides. There are different sources, but there are also different people who are acting on that same source, right? So that's where it multiplies. I don't have the number, but when I did the last calculation, this particular Lambda system that we built internally processes about 20 billion transactions a day, right? So there are one of the sources that you see up there is our user interaction service. Basically, anything that you do on our site, we record it. So that's huge. And then we have our access logs. So there are two other sources, I forgot now. But the number of transactions that we do is about 20 billion messages. 20 billion computations in a day, right? And sometimes the computation may do nothing, but at least it gets invoked at that many number of times. So that is a system that we have built, and we can build these systems. We have the developer who built that as well in the room. So if you want to ask questions about it, feel free to stick around. And again, I want to wrap up with the benefits that I wanted to mention. So the one that I mentioned earlier, what is Amazon Lambda, and what are the different benefits you get, right? The first one, as I mentioned earlier, we spend about $550 for about 2.3 billion transactions. Again, cost is where it really helps with the cost. There is no server to patch, right? So the server is always there because Amazon is just triggering your function, and you don't have to go and manage a server to patch it and whatnot. So that's where there is zero administration that you have to deal with. That's operations. And the scale, right? Like as you have more requests coming into the system, you have the number of times that you can run the Lambda also increases, right? And the biggest one that I really wanted to emphasize is the opportunity, right? There are a lot of things that you could build yourself, but you have to spend a lot of time figuring out how to build, like DynamoDB, how do I build the SNS notification system. All of those you can just do like use Amazon services, DynamoDB, API gateways, SNS, S3 events, and even the recent CloudWatch, CloudWatch scheduler as well, right? Based on you are able to scale your trigger your lambdas based on that. And then as I mentioned, showed earlier, it literally took me to create my lambda like 10 seconds. And if you have an idea, a very small idea that you want to go and operate on it, you can actually try it and see if it works. If it doesn't work, you throw off, right? Like that's what microservices were also microservices was also giving you. But in this, it is just a simple function that you are running, and the execution time is pretty less versus like how do you build a server with microservice, go and figure out whether how do I write a chef cookbook, how do I write a Docker file or whatnot. In this case, you are just running your function basically. Right? So what do we want to do as going forward, right? I don't know, recently Amazon Gateway added support as a proxy to Lambdas. Before that, you actually had to do like transformation on the messages that you got in. Recently, Amazon added full integration with API Gateway and Lambdas. Basically, when you are done executing a Lambda through API Gateway, all you are doing is sending a response code, HTTP response codes, and then that's what the end user will also get. So we are going to improve that support in our platform, the primer platform that I mentioned. And currently, again, Lambda supports logging to CloudWatch. It's by default it does. But we use Splunk and other sources as well. So there are some teams who wants to use write the logs directly to Splunk as well. So more than providing that at a platform, we are probably looking at work with the teams to make sure we can have some connectors that go into CloudWatch, into Splunk as well. And Again, this is a spike. We have our hotel images that we run in our system. Right? There is a media server that runs in Amazon. It uses Zookeeper, SQS, and those mechanisms versus running through Lambdas. Like whenever a new image comes in, we do some processing on top of it. When they were trying to do this in Amazon, at the time, VPC support was not there for Lambdas. Again, it has been there for a while now. So we may look at doing it. And also, with the latest announcement that Werner did today with the state, like managing the state with Lambdas and whatnot, so that really helps us, again, go and revisit whether we can do that with purely just Lambdas versus the current Zookeeper ecosystem that we have. Again, again, my intent with the talk is we do a lot of things. There are different other use cases that we do as well. I just want to share the different patterns that we are doing at Expedia. See if you can learn from that and use for your systems as well. Thanks, everyone.